We're continuing with Brad World's story problems. George helped another farmer plant tomato plants. There are 48 tomato plants per row. At 10 o'clock, they planted 5 rows. How many tomato plants did they plant? So in every single row, really, well, first let's start with this. At 10 o'clock, does that really matter? Not right now, no. But what does matter is that they planted 5 rows. So if I picture 5 rows, 1, 2, 3, 4, 5, and then I know in every single row there's going to be 48 plants. So there's 48 in this row, 48 in this row, 48 in this row, 48 and 48. And now the question is, how many tomato plants did they plant in all? So you can either use an addition equation or a multiplication equation to solve this problem. Go ahead and pause this video so you can solve that now. Next, by lunch, they had planted a total of 15 rows. How many tomato plants did they plant? So now we not only have this row of 5, but we have 2 more rows of those 5s. So your picture might look a little bit like this now. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And something I noticed now is I could put 48 on all of these again and go 48 plus 48 plus 48 plus 48 plus 48, right? And that would continue on, and I have to do that 15 times, which you can do. Or I can notice that I have 3 groups of this 48. So whatever my answer was for A, I can multiply that by 3 to get how many plants are in 15 rows. Go ahead and pause this video to solve this problem now. 4. Is the equation true or false? So I'm gonna first start by drawing my line at the equal sign, and I'm gonna compare each side. I'm not actually gonna solve 27 times 15 and then solve all the equations on this side. I'm looking for patterns in the factors. Remember, a factor is what you multiply to get a product. So I have 27 times 15, and I notice here I have 20. Okay, and I know that there I have part of 20, and here's the 15, that's a check, there's 15. And then I have minus 7. Now here's the 7 here, and I think that's how they got the 7 on the right-hand side of the equation, and there's the 15. But if I do 20 minus 7, that's going to give me 13. So this problem is actually, this side is expressing 13 times 15. So you're going to decide, is that true or is that false? Did I get 27? Do I get 27 by doing 20 minus 7? And you're going to write your answer here. If you need a little bit more time to think, feel free to pause this video. I'm going to draw my line again for my equal sign. And now I have 45 times 18. So I'm going to see, can I make up both 45 and 18 in both of these, in all of these parentheses over here? And it looks like we've broken it up into a partial product. Remember, when I'm looking at a partial product, I'm looking for, do I have 10s times 10s, 10s times 1s, 1s times 1s, and then the 1s times 10s for each of the place values. So I'm looking for, do I have 40 times 10 and 40 times 8? Do I have that? 40 times 10 plus 40 times 8. That looks like a check and a check. Now you're going to check, do I also have the other side, my 1s times 1s? Do I have 8 times 5 and 10 times 5? And if you do, you're going to put true on this side. If you do not, you're going to put false. Problem C looks like 99 times 31, and that looks like a over-under strategy. 99 is very close to 100. I would just need to subtract one group to get to 100. So you're going to see, does this side reflect that? If it's true, you're going to put true. If not, you're going to put false. And the last one, 64 times 15, I'm going to look over on this side, and it looks like I didn't do a distributive property, a partial product. I'm not close. So that leaves one strategy, and that most likely is going to be doubling and halving. So I'm gonna check, did I double one factor and have the other? So for example, 64, I can see that I halved it. This is in half. 32 is half of 64. So there's my half. So now you're gonna double check, did 15 to 30 double? If it did, it's gonna be true. If it didn't, it's gonna be false. Number 5, write an expression for each item. For this one, you do not have to solve it. You're just writing the expression. Here's the example. To find 12 times 17, first I multiply 10 times 17, and then I add 2 times 17, and I add those two products together. There's that addition. Let's take a look at this next one. To find 79 times 24, I'm gonna multiply 80 times 24, and then take off. Take off means subtract one group of 24. So you're gonna have your parentheses with your first multiplication part. You're gonna take off by subtracting, and then your one group of 24. So you're gonna fill in those blanks. To find 12 times 13, I double 13 and have 12, and then I multiply. So you're doubling 13, and you are making an equation for this. Double means you're multiplying by 2, and then you're having 12, which means you are dividing by 2. Remember, I'm not looking for an answer on these. I did give you a little bit more on this one because I was gonna put divided by 2, but that would have been on the wrong side, so that part is already done for you. Last, this is the challenge, to find 1,188 divided by 12. I think about 1,200 divided by 12, which is 100 groups of 12. The divisor, 1,188, has one fewer group of 12. So you're going to see when you write that out using your parentheses, how would you need an operation right here as well to then finish that last group. See what you can do on that one. Great job.